Welcome to WeldForm channel. In this channel we will be seeing some mechanical, thermal and mechanical thermal couple problems solved with different numerical approaches like finite elements, smoothed particle hydrodynamics, XFEM, particle FEM, etc. So, in this video we will be seeing this problem which has been solved in the last video, but in this video we will be adding some thermal coupling. The last video were about solving this problem with only a mechanical approach. It's a simple mechanical compression test, but now we will be adding some thermal coupling. So the first thing we have to look is in the output obtained in the last video. If we open that in Paraview with load states, this is a template done by me, but you can use whatever you want. I will be adding this on the description in some Google Drive folder. So we open this, and here we have the output obtained in the last video, in which we have only plastic strain, but it's not temperature obtained. So we have stress and plastic strain also, but we have not any temperature obtained. So we want to also account for temperature increase, which is in fact increasing due to the heat generated by plastic strain. So the input used in the last video is shown here. It's a compression mesh.json, and is this input. If we want to solve this couplet problem, we will be downloading. The last version of WeldForm, which is here. This is the last version of WeldForm. Do not download this because this last version has several hotfixes included, which accounts for improving the opening of JSON files. So this is the file with which we begin. If we do not put anything related to the solver, the default solver in this file will be mechanical one. So once we have downloaded the last version of WeldForm, we can copy the path and open a cmd command line. And once we are here, we can open the input file, the mechanical input file. We can copy that and paste it to some file name we want, and we will be adding the several lines. The first one is the line related to the type of solver. If we put this solver, this will be a mechanical thermal couplet solver, and this solver is accounting also for different time step sizes. But we can also put this with this, which is a solver. Is in fact the solver used in this work, and it's not the leapfrog. Exactly the leapfrog standard method for time integration, but it's the same in this case if we have not a variable time step, but this solver is working only with constant time steps. So it's the same. Since we will be using a fixed time step, it's the same to use each one. So particle radius, H factor, these are all geometrical factors. This is a factor containing the time step things. Time step will be put as false, auto time stepping, sorry. And here we can also add the amount of processors, and we can here add these two lines in materials, in which we will be adding the thermal conductivity and thermal heat capacitance of the material. So we put here, and the last thing we have to do is to put an initial condition on the bottom of the JSON file, or can be located in any place. This is saying that initial temperature is about 20 degrees. So if we now go to the command line, we can run this problem, put in the input file. This is our input file, compression mech. I want to show you how WeldForm runs with only the mechanical input. So we can here see that the solver used is the standard leapfrog variable time step solver, but here is the energy, displacement, plastic strain, and so on, but it's not any temperature here. So if we put this, but instead of mech we put thermal, now we are viewing temperatures which are increasing. So finally, if we wait until the problem will run up to the end of the time, this is the end time, is about 10 cents of seconds. So 10 thousandths, I'm sorry, of seconds, and we can read it here. Load state again. This is the template, but I have saved here the mech and thermal things, and here we are open the last output of this file. So we can see here which is the temperature in the central zone of the cylinder, which in fact is also the same obtained by finite element approach. We will put this here and here, and about 47 Celsius degrees. So by putting these parameters, we are solving now a mechanical, coupled, and thermal problems. Well, if you like the video, please subscribe to the channel. I will be adding some complex problems in the following videos. Bye bye.